Mr. Pena, who used enterprise to spoof and made millions of dollars. But that's still a cost. But what we're going to show here in a minute that shows is not only affect the voice, but it can affect the data. That's where the cost will translate into liability, right? How do you mitigate the liability if your customer information is lost? And it's getting to the point where, it's close to the removable devices kind of model, where you got to treat the Voip security similar to the way you treat the USB devices or something similar to that. So the risk profile. Now, Peter had a wonderful session. He talked about an hour on that protocol vulnerabilities. I'm not going to go deep into this, but many vulnerabilities exist. We all know that, thousands of them we discovered. Other people are discovering those. But the important fact is the implementations are vulnerable. The protocols are not complete in security because there's a limit to where the security becomes a usability problem. So you got to have that balance. So the protocol vulnerabilities can be solved by implementation, but many of them continue to persist as this application matures, just like what we have seen with email and other data applications. Here is a simple example I want to show you. I'm going to use this again in my attack demo. I can just replace the URL in the from with a very lengthy stuff which is causing a buffer overflow. And the buffer overflow will create the shell to execute on top of it. A very simple attack. And second, I can spoof the caller ID very easily by substituting the string caller display name with somebody else. So now I can act like my CEO. So these are a couple of simple examples, but there are many more, thousands of more, which can be used to attack the call servers, attack the voicemail. Imagine voicemail, right? Most of the voicemail systems trust the caller ID as a account or PIN number to get to voicemail. So a reconnaissance attack such as this could end up opening voicemail to the hacker. Okay, so with that, I would go into more how to build these attacks. I mean, this is very simple. There are simple techniques. Use third-party solutions, public tools like Cybers, or you can download a whole bunch of tools out there. But before that, let me show you these protocol stacks. Particularly in dual mode phones, on the left side, this used to be existing today with closed cell phone. These are all the layers that are closed, and the only telephone application that exists on top of it. Now that's changing. We are adding these layers here on top of it. We are adding SIP. We are adding APIs from SIP into applications that you can write on top of it, integrate with Outlook, integrate with other applications. So these, now you can start jumping between these two, right? So I can start here in the SIP world and migrate into cellular world and vice versa. And as I said, the impact will be huge. I can not only affect as an attacker, if I'm an attacker, I'm using a dual mode phone with SIP client, I can not only attack my SIP side of it, I can also attack on the cellular side of it. So it takes just a couple of scripts. And it can be attacked too. I mean, we will have a couple of demos where you just send a message to a dual mode phone, it crashes. So I have several of those models. I'll go into that. Then these tools, it's very easy. Just take a laptop, download Cybers, download whole bunch of scripts from the internet. These already exist today. You don't have to create any. They can be used to attack whole bunch of systems in your network. Protoss is a good example. People can download and launch. So you may have an implementation that kind of blocks those or processes it but drops it, but it can create a network overload. These kind of scripts can send thousands of messages per second. And we know that I came from building soft switches and voice over IP systems, and we always talk about 10 calls per second to 100 calls per second is the kind of a capacity of these servers we're talking about. We're not talking about thousands of transactions per second. We're talking about 10 to 100. How easy it is to launch an attack that can overwhelm PBX, that the legitimate user stop getting a dial tone. So easy to create vulnerabilities, find vulnerabilities, easy to create attacks. Now actually I want to, there are several tutorialish slides we had in the original presentation. It's there on the web, you can download, but I really want to jump into the attacks or vulnerabilities that we discovered, more importantly than spending more time on the tutorials. So if anybody interested, they can download those. So these are the real vulnerabilities. It's not theory anymore. We found these vulnerabilities. We took the vulnerabilities and created exploits. And we have tools like Lava, our own tools, where we can script these like in a minute. You can use Perl script, Python script, or anything like that, as well as more sophisticated call flow scripts can be created using the tool. So with that, let me go into there are many vulnerabilities that we have discovered and launched against it and submitted the advisory. Some of them are into cert right now. So we know the format string vulnerability, buffer overflow, failure to handle malform delimiters. These are all real. These are all the real devices that are unable to process those or crash or can do buffer overflow. Server impersonation. So I'm going to go quickly into the details of each of these vulnerability. First, format string. It's very easy to create this kind of thing. Many phones are vulnerable to format strings. As you can see here, what I replaced characters with just percentages. This kind of implementations happen because the phones are less in processing power. If you look at it, unlike servers where you could do all kinds of security checks and all those things, the phones have very less memory, less processing. So they usually have a brute force way of developing applications, and they're more vulnerable because of that. And on top of that, there are thousands of these. It's very hard to patch them on the field. So one of the phone, we're going to demonstrate this attack, which kind of causes a denial of service on the phone. Second one, this is an important buffer overflow attack. We replaced URI from URI with some large junk followed by a shell code. The shell code is very simple. It just goes, executes on the native system while you have other security products such as Windows Firewall, McAfee, Total Protection is running on top of it, because it's running in the context of the phone. When you bring up an application, even with Cisco CSA, you'll ask whether to allow or not. That's a good practice, but when you bring up soft phone, I can show you that, you have to say, yes, allow it. And after you say allow it, all bets are off. right? These vulnerabilities can be used to cause buffer overflows, thereby getting control of the laptop and attack and then copy the files. Sorry. This is another example. SIP in particular, and there are other protocols as well, are very loose in grammar. It's created for a purpose, to be very open, extensible, so that I don't have to do thousands of interoperabilities. I can fix it easily and add it easily. So the value of SIP is making interoperability easy. That's a major focus of SIP. So in order to do that, the grammar is very flexible, friendly, modifiable. So the same thing can be used by the hacker. Now here we can see a bunch of delimiters that we added and end up crashing a couple of soft phones. This is a syntax error. I mean, phones, because it's so loose, so many variations are possible. You naturally have the ability to craft a message that can take advantage of the looseness in the protocol implementations. So here is an example. I just there's a syntax error here, but end up crashing a phone. This is another thing that Peter was talking about, impersonation. There are two things that you can spoof in voice over IP systems. You can spoof IP address, you can spoof caller ID. I mean, many of the devices are behind NAT today, right? All you see is a public IP address, public IP port. And what is behind it, you don't know. It could be a legitimate endpoint, it could be a spoofed endpoint, right? So I could pretend to be something else. I could pretend to be server. Now, because the phones are like servers, they're ready to receive messages. So when they're ready, port 5060 is a good example. Every phone opens port 5060. Every phone opens port 5061. These are the ports that are used to connect to the phone. In the event, you need to complete a call. So it's a legitimate request. The same legitimacy can be used by the hacker to cause a denial of service. So in combination with some of the other attacks that we showed, impersonation plus buffer overflow, you have a deadly weapon. Sorry. This is another example. I told you about the resources on the phone, right? I mean, the phone has only certain resources can process, let alone call servers. Call servers can also crash if you overload them, but phones can crash much sooner. If I make 1 call a minute to your phone, is it dead or alive, right? That's an example. So we send some of these messages at low volume, and it's a noise in the network. It looks like very legitimate. I mean, if I'm making a call and breaking a call a couple of times, it behaves like that. So a network device or a security device cannot even detect such